In this video, I am going to find the arc length for a cycloid for the interval 0 to 2 pi. Theta ranges between 0 and 2 pi. Cycloid is defined by x is equal to r times theta minus sine of theta, and y is equal to r times 1 minus cosine of theta. Now, the arc length formula for parametric curves is given by this. The parameter in this case is theta. So is going to be integral a to b square root of dx over d theta whole square plus dy over d theta whole square d theta. This d theta is outside of the square root. In our case, a is equal to 0 and b is equal to 2 pi. And we just need to simplify the dx over d theta and square it, and similarly for dy over d theta. So let's do it here on the side. Dx over d theta is going to be the derivative of x with respect to theta. So it's going to be just r times derivative of theta, which is just 1, minus r times derivative of sine of theta with respect to theta is cosine of theta, which is basically r times 1 minus cosine of theta. Now I need to square it. So I need to square dx over d theta. If I square it, I'm going to have to square this. That's going to give me r square times 1 minus 2 cosine of theta plus cosine square of theta. I just use the formula a plus b whole square. Now, similarly, I'll find dy over d theta. My y is right here, so derivative of r with respect to theta is going to be 0 because r is a constant. Then derivative of cosine of theta is negative sine of theta. So this negative with negative sine of theta is going to make it positive sine of theta. So it's going to be r times sine of theta. And this one is pretty straightforward. This would imply that dy over dx whole square is nothing but r square sine square of theta. Now I'm going to take this value and plug it into this integral along with the limits of integration. So that's going to give me L, the arc length, integral 0 to 2 pi square root of, this one is going to be r square times 1 minus 2 cosine of theta plus cosine square of theta, then plus r square sine square of theta. So if I combine it, it's going to be sine square of theta, then of course outside of the square root d theta. That's going to give me integral 0 to 2 pi. Now there is an r square under the square root. I could just take it outside because r is a constant, which is the radius of the curve here, or radius of the circle in this case. So it's going to be is equal to square root of 1 minus 2 cosine of theta. Actually, it's going to be 2 minus 2 cosine of theta because this is 1, right? Now, this could be simplified. So don't forget the d theta. So 2 minus 2 cosine of theta, which is just basically 1 minus cosine of theta. We could factor out the 2. So 1 minus cosine of theta. That I could write it as 1 minus cosine of 2 theta, kind of like 2x. 2 times theta over 2. And then I'm going to use the formula for cosine of 2x, right? Cosine of 2x, remember, is equal to cosine square of x minus sine square of x, which could be simplified in either way you want. So cosine square of x is 1 minus sine square of x. So it's going to be 1 minus 2 sine square of x. So using that formula, I could simplify this to 1 minus 1 plus 2 sine square of theta over 2. Now this and this are going to cancel out. That's going to give me 2 sine square of theta over 2. Now I'm going to take this and plug it into this. So I'm going to have L is equal to R times integral from 0 to 2 pi times square root of 2 times 1 minus cosine of theta, right? But that is going to be 2 sine square of theta over 2 d theta. Then L is equal to R times integral 0 to 2 pi. Okay, now 2 times 2 is 4 under the square root. If I take it outside, it's going to be just 2. So I can put 2R here. And then I'm going to be left with sine square theta over 2 square root of it. That's going to give me just sine theta over 2 d theta. Now the integral of sine of theta over 2. So let's go ahead and write it out. L is equal to 2R times integral sine of theta over 2. By the way, that is going to be negative 2 times cosine of theta over 2. And this is evaluated from 0 to 2 pi. If I simplify it a little further, I'm going to get this 2 times 2, 4. So it's going to be negative 4R times cosine of theta over 2 evaluated from 0 to 2 pi. That is going to be equal to, so L is equal to negative 4R times cosine of 2 pi minus cosine of 0, right? Now cosine of 2 pi is going to be negative 1, right? And cosine of 0 is 1. So that's going to give me negative 4R times negative 1 minus 1. That's going to give you negative 2. If you simplify it, it becomes 8R. So the arc length L is going to be 8R. I hope that this discussion was helpful. Thank you very much.